Okay, so we're going to go over through problem solving with quadratics. So we'll just say that somebody's standing on a cliff and they've decided, there they are, to throw a ball off the cliff. And the trajectory of the ball is modeled by this equation here. Do you guys use f of x? No, you guys use y, right?
Yeah.
Yeah, sorry. I was doing something else before. Okay, this is the trajectory of the ball. Y is equal to this. So there's quite a few things we can figure out. First of all, we might want to know how high was the ball thrown from. Let's kind of assume that it's essentially the height of the cliff is how high the ball is thrown from. Well, if we're modeling this in terms of a graph, okay, essentially what's happening is the trajectory of the ball, our x is time. X is how much time has passed. And we can call it maybe in seconds, where y is our height of the ball. Okay. Now, the ball will be thrown when we are at what time?
0.
0. When we're at 0, that's when the ball will have been thrown. So 0. So essentially is wherever the starting point is whatever the height of the cliff would be, because that's when the ball is originally thrown. Now, luckily, in standard form, I can find and this is known as the Y-intercept, I can find the Y-intercept very quickly. What is it? Do you recall?
It's 40.
Yeah, it's whatever our C value is. Let's write these values in, because this is our A, B, and our C. So our C value is 40. So in other words, let's assume that's 40, 0 and 40. 40 meters, let's say it's in meters, is the height of the ball when it's originally thrown from the cliff. So assuming that the ball is thrown from the edge of the cliff, the height of the cliff is 40 meters high. Okay. Now maybe they're going to go ahead and ask us how long is the ball in the air for? Okay. And well, to figure out how long the ball is in the air for, assuming that the ball is thrown, it eventually comes and hits the ground. What is this known as when it hits the ground?
It's 0.
Yeah, it's known as 0. It's also when, if this crosses below, when it's crossing this line, X intercepts. Okay. Okay. Now, can the ball be negative in height?
No.
Reference to the ground. Not unless it has a drill to it and drills through the earth, right? So we go on the assumption that the ball is hitting the ground when it hits the X intercept. So one way to find X intercepts is I might be able to factor this. Factoring is one way, or I can put our quadratic formula in, right? Negative b plus or minus the square root of b, and I'll try to color code it for us, squared minus 4 times a times c, all divided by, so all of it is divided by 2a. Okay, so this is always in reference, this quadratic formula, to standard form, our a or b or c. It has nothing to do with vertex form or factor form, because otherwise we don't have an a, b, and c.
Yeah.
Okay, so we take these values and we essentially plug them in. Now, usually with x-intercepts, and especially with this one, we're going to have 2 of them. Okay, and we'll talk about the realism between the 2 in a moment. So let's work on just solving this for now. Our b value was 8. Okay, so we have x is equal to negative 8. Okay, now if it had been a negative 8, it'd be negative 8, which makes this positive. Okay, plus or minus the square root of, we still have our 8 squared minus 4 multiplied by a is negative 4 and c is 40, all divided over 2 times a, and that would be 2 times negative 4. Okay, so you might want to get a calculator out so we can kind of work through this together here. Alright, so I'm going to try to simplify a few of these. This becomes negative 8 plus or minus the root of 8 squared is going to be 64.
Yeah.
Okay. That gives us... Now, negative 4 times negative 4 is going to be... A negative times a negative is a positive.
16.
Yeah.
Plus, I mean, times 46.
Times 40. So...
Oh, that's 40.
It'd be 460.
640.
Oh, I had it backwards. 640. Good. And it's going to be a positive value because it's a negative times a negative, which is a positive times a positive. Okay?
Yeah.
And then all of that will be divided by negative 8. We add up our values underneath. So we're finding the root of 704. And I remember you saying your teacher likes to keep things exact.
Yeah.
Okay.
So
So the root of 704 is not a nice number.
yeah.
So what ends up happening here is we split the equation here. So we split the equation. The reason we do that, we have x, and remember we're always solving for x. Okay, we're finding the x-intercept. X is equal to -8 plus the root of 704 divided by -8, and x is equal to -8 minus the root of 704 divided by -8. And I'm going to just put these in red so that they stand out. One is when we add the values, the other is when we subtract the values. Okay. Now from there, this is technically an exact value, but we need to make sense of this because they want to know exactly how many seconds it takes. Well, I would never describe to somebody it takes -8 minus the root of 704 divided by -8 seconds. I would actually give them a value, and it will be a decimal. So let's actually work this out. What is the root of 704?
It is 26.5.
Perfect. 26.5. Great. So approximately plus 26.5 divided by -8. And in this one, we have -8 minus 26.5 divide -8.
Don't the -8s cross out each other?
Actually, they don't. And the reason being is because there's an addition and a subtraction sign. Right. If this had been multiplication, then you're right. Okay? But because it's adding and subtracting, the only way to factor out, say if this was a round number, I'll give you a better example. Yeah. Let's say we had like 6 and 8 divided by 2. Well, then I can divide both these by 2. And then that would give me 3 plus 4. And that would be the same thing.
Yeah.
Okay?
18.5.
Okay, so that's the number on top. 18.5 divided by -8. And here we're going to get -34.5 divided by -8, I believe.
Yeah.
Okay, and then we have to divide these. So as an actual value,
-2.3.
Okay, and what's the other one?
-4. Yeah.
Okay, let's make sense of this. -2.31 seconds. So remember we said we're going to find two x-intercepts. That would essentially be this value. But in terms of what we're doing, is there a -2.31 seconds? No, that would essentially be when this guy's like climbing up the cliff or something.
Yeah.
Right? So that makes no sense. That's an illogical answer for what we're doing. So
yeah.
we wouldn't say it's going to hit the ground either 2 seconds before it's thrown or 4.3 seconds after. You would only use this answer here in this case. This answer is it hits the ground 4.31 seconds after it's thrown.
Okay. What if it was two positive numbers? What if it was 2?
Then at two positive numbers, what that means is we try to graph the relationship that it was probably the timing started, then the ball's thrown up in the air, and it comes back down. So it was probably thrown from the ground. That's what it's saying. Otherwise, if it's thrown from a cliff, it needs to be thrown somewhere up on our y-axis.
Yeah.
Okay? And the negative value doesn't really make realistic sense with what we're trying to find. Okay?
I think I got it right. Because I got one.
The other thing they can ask us is, what is the max height? Which is essentially the vertex. Now, from the two x-intercepts, I can find the equation of the axis and all those silly things. But another way we can find this is completing the square from the original standard form.
Yeah.
Okay, so maybe I'll jump to the next page here. And the original equation said y was equal to -4x squared plus 8x plus 40. So let's complete the square. If you recall, completing the square, we take the original a value, and we divide both the first and the second number by it. In fact, we essentially use it as a common factor and pull it out of the first two values. So it becomes
-4.
Yeah, -4
bracket x squared plus minus 2 x plus 40.
Yeah. Now, does your teacher teach you to keep the 40 in the bracket or no?
No.
Okay, good. So we'll keep it out this way. Then from here, what do they tell you is the next step?
You divide -2 by 2, and then square it.
Yeah.
So you find the other number.
Exactly, and that's what this little formula is there to help you. So we have what's you can consider as a new b value.
Yeah.
So we take this and plug it into this little formula here. So it ends up being a -2 divided by 2, which is -1, right? And -1 squared is 1, right?
So, and our teacher shows us to put the 1 in the bracket, but also put -1.
Yes. So you add and subtract. And the reason being for this,
so it keeps it balanced.
Exactly, because essentially +1 and -1 when put together is 0. So I'm not really adding or taking away anything from this equation. Now, the whole point of this is to do something called find a perfect square trinomial. Yeah. And these 3 values now make a perfect square trinomial. This one does not help.
Yeah.
So we take this out of the bracket.
And then multiply it by -4.
Exactly. You multiply it by whatever your a value is, so it has to be multiplied by -4. So the next line might read -4 x squared minus 2x plus 1. And then when it comes outside, it becomes
plus 40. I mean 4.
Yeah, and then we still have to do our plus 40. Okay. Now, what did they teach you from here?
I don't know what it's called, but find a common factor.
Oh, okay.
So I mean, well, no, find the.
You can factor this the way you normally factor a trinomial, but there's actually a shortcut to this because you've created something called a perfect square trinomial.
Yeah.
You just need to square root the first and last terms.
Yeah.
Yeah. So if we find the square root of x squared and the square root of 1, they become
1.
X and 1.
Yeah.
So in other words, we get -4. And we have our bracket and we square it because we're turning it into vertex form. I have x and 1, and then whatever the operation in front of the middle term is, we just bring that down. So it becomes
But isn't -1 what we got by dividing 2 by 2?
It is. -1 is the value we got by that.
And
that'll essentially always be what their number is. Yeah, you're right. Okay. So, and we added these together. Here is our vertex very quickly.
Yeah.
Okay. And essentially what it is at +1, right?
And 44.
And 44. So after 1 second, or 1 second after being thrown, the ball is at its max height of 44. So it goes up another 4 meters and then starts to descend from where it was before.